Here we are going to discuss how to evaluate a geometric series. It says work out the sum from 1 to infinity of 243 times a third raised up to the n minus 1. So this is a sum of a geometric series from 1 to infinity, from the first term up to the infinite term. Now, a geometric sequence is a sequence of numbers in which the ratio between consecutive terms is constant. There's a common ratio. A ratio means divide. So when you divide the following by the previous, you'll get, and you do that at least 2 times, you will get a ratio that is common. Just remember, ratio implies a division. A geometric series results from adding the terms of a geometric sequence. So series implies you've got to sum. So that's where you have the sum symbol. Series implies sum, and sequence is separated. The terms are separated by a comma. So the formula for the partial sum of the first n terms of a geometric series is, here you have it, the sum from 1 to n. So that's why they call it partial. For the first n terms is A. A means the first term, R is a common ratio, raised up to n minus 1. And here's the formula for the partial sum, where A is the first term and R is the common ratio. No, this example is not for the partial sum. This is a sum to infinity. So we need another formula for the sum to infinity of a geometric sequence. So here's the formula for the sum to infinity, okay? S sub infinite, here's the infinity symbol, is equal to the first term represented by A sub 1. Sometimes some formulas use just A, or some use A sub 1, divided by 1 minus R. R is the common ratio. No, R must be between negative 1 and 1, okay? A is the first term and R is the ratio, the common ratio. As you can see, R is equal to the following divided by the previous term. So that's how you calculate the ratio. If you have the terms, AN means the following term, AN minus 1 means the term before. Okay? So the term after divided by the term before will give you the common ratio. Okay? So this is the formula that we have to use to solve that problem. So let's go back to the problem. So as you can see, we have identified the first term to be 243, the common ratio to be a third, and we're going to find the sum to infinity. The formula is very simple. All it requires is the first term and the common ratio. And as you can see, this expression resembles very much this one, but we went from 1 to infinity. Here we the solution forgot to write 1 to infinity. All right. And A is 243. R is a third, and N is infinite. So it's a sum to infinity. So we just have to substitute 243 in the place of A. Here it is. A over 1 minus R. 243 over 1 minus a third. Okay. So you have 243, and 1 minus a third will give us 2/3. Here it is. And we're going to apply keep, change, and flip. So we keep 243 over 1. We change division to a multiply, and we flip this fraction to 3 over 2. And then here we have it, 243 times 3 divided by 2 to give us a final answer of 364.5. Working out the sum to infinity of a geometric series. So pause the video, take out your pen, pencil, paper, your calculator, and participate in this video. work it out yourself to see if you get 364.5. And that's the way to learn any mathematical concept from a video. You must participate whilst viewing the video. Try it yourself.